In this video, we're going to look at implicit differentiation. Up to this point, you've been dealing with what is called explicit differentiation. And I guess the best way to explain that is in explicit differentiation, your expression is solved for y. So you got something like this. And you're asked to find the derivative. Here are the notations here on the note. If y is equal to f of x, then y prime is equal to dy over dx, f prime of x, the derivative of f of x, and then using operator notation in the last two, derivative with respect to x of y, derivative with respect to x of f of x. Those all represent the same thing. Okay, so whenever I use a y prime, same thing as dy over dx or f prime of x and so forth. So this one is written explicitly. So you just use your basic formulas, and I'm assuming that at this point you know your basic formulas for differentiation or for computing the derivative. So the derivative here, or y prime, will be given by step here. Derivative of x squared is 2x. Derivative of minus x is minus 1. Derivative of a constant is 0, so you get this. Okay. This one is written explicitly. Now let's suppose we have one like this. X plus y equals to 3. Okay, this one is not written explicitly because it's not solved for y. But you can easily solve it for y by just doing it, right? Y equal to 3 minus x. And then you just compute the derivative and say, okay, dy over dx. Again, I'm going to use the easiest notation, which is just y prime. And the derivative of 3 is 0. Derivative of minus x, again, is minus 1. So there you have it. Okay. Now, you won't always be able to do that. Okay. Sometimes you're going to come up with some problem where you cannot solve it for y. So you have to do it implicitly. So basically, if you're going to do it implicitly, here are the things to note. Just treat y as a function of x, just like no different than if you have something like 2x plus 1. Say that's taken to the third power, and you want to compute the derivative of that with respect to x. So power rule, combination with the chain rule, you go, okay, 3 times, instead of cubing this out, or say this is to the 20th power, you don't want to take the power to that. So we leave it in that form. We say, okay, this will be 3 out here. 3 multiplies the coefficient over here, which is 1. And this will be 2x plus 1. Subtract 1 from the power there, makes it a 2. And then multiply by the derivative of what's inside here in the parentheses. Derivative of 2x plus 1 is 2. And multiply out to simplify. 2 times 3 is 6. And we get the derivative then is 6 times 2x plus 1 to the second. Okay, so that's what you have to do. They say this is a y. Okay, when I take the derivative, you do the same sort of thing. So over here, if you compute the derivative of y dx over dx, that's just going to be y prime. If you're taking the derivative of y to the n with respect to x, then using your power rule, this would go again, n times the 1 here, subtract 1, and then you multiply by the derivative of y with respect to x. So, because it's a function of x. Okay, if it's just y, it's just going to be y prime. But if it has like a power, this is the way you're going to set it up. So again, instead of using this dy dx, I'm going to abbreviate it and just say y prime. Okay. So in the one that I had a while ago, or something similar to what I had, x plus y, say, is equal to 3. You could solve that for y. But if you do it implicitly, leave it that way, you just take the derivative term by term with respect to x. Okay, the derivative of x with respect to x is 1. the derivative of y with respect to x is only y to the first, so that'll just be y prime. And the derivative of 3, that's a constant, that'll be 0. So y prime. Solving it will give you a negative 1. Okay. Okay. But this is basically what you would do when you're computing the derivative using implicit differentiation. You're treating y as a function of x, so you're applying basically your power rule, and it's going to look like this. Okay, so let's clear this. Go to the next one. So again, we want to compute the derivative with respect to x using implicit differentiation. Okay, so this one here, again, we're going to do it. This one I'm going to do both ways. Notice I can solve it for y. So if I bring the x squared over, make it a 9 minus x squared, and then take the square root plus or minus, this is what we get. Okay. So now, first I do it using implicit differentiation. So using implicit differentiation, then I would just say, okay, the derivative of x squared, without solving it for, without solving it for y. Okay, this would just be 2x. Okay, and the derivative of y squared, okay, so again, applying this formula right here, this would just be then 2 times the 1 there, and then subtract 1 from the 2, we get 1 here, and then you multiply that by the derivative of y with respect to x. Again, I'm just going to use y prime here. The derivative of a constant is 0, okay. So then, this will then give me 2y. Y prime equal, I'm solving out for y prime, so bring this over, minus 2x. Okay, so the 2's are going to cancel out here. So you can see that y prime then is going to equal 2 divided by y minus x over y. Okay, so this is the derivative using implicit differentiation. And again, implicit differentiation again just simply means that the given expression is not solved for y. So I take the derivative implicitly using these formulas. Now notice if I do it the other way, if I just leave it this way, write it explicitly, and I compute the derivative, then okay, this is going to be y prime. Okay, so going from here. Okay, so I'm going to look at this side over here. Okay. So using the power rule again here, 1/2 multiplies the coefficient there, so that's going to be plus minus 1/2. This will be 9 minus x squared. Okay, and then we subtract 1 from the 1/2, makes it a minus 1/2. Okay, and then times the derivative of what's inside. The derivative of 9 is 0, and the derivative of minus x squared is a minus 2x. Okay, so then, now this 2 here and this 2 here are going to cancel. And then I'm going to take the radical here, minus 1/2. If I take it to the denominator, it becomes a positive 1/2. So I'm going to put it down here. So this will be 9 minus x squared. That becomes positive 1/2 using the rules for negative exponents. And the plus or minus here, I'm going to take it to the bottom. So this will be plus or minus. Okay, and then on top, this minus is going to stay there. That's going to be minus x. Okay, there you have it. So then this is going to equal, okay, so notice it doesn't look like this answer, but look, minus x is there, and then plus or minus 9 minus x squared to the 1/2, that's just y. Okay, so there you have it. There it is. Same answer. Okay. first do it, you're thinking, well, it doesn't look like the same answer, but then just doing a little bit of substitution here comes out the same. Okay, so this one I could have done either way. Obviously, in this case, it's easier to use implicit differentiation. You don't have to go through all of this, right? So now let's go to one where it's a little bit difficult, more difficult to solve for y. So this one I did it both ways. So let's go to this one. Okay, so here we have x cubed and xy plus y squared here. So that's a little bit difficult to solve it for y. So I'm going to do this implicitly using the formulas. Okay, so again, take the derivative term by term. Now if it's an x term, it's just regular differentiation. If it has a y or y to a power, that's when you use this idea of y to the n, okay, and use the formula that I just went over. So this one, that's good. Derivative of x cubed is 3. X squared. Okay. Plus. Again, we're taking the derivative term by term. So the next one has an x and a y. But remember, y is a function of x. So you have to use this as a product of two functions involving x. So you have to use the product rule. So this would be then, it'd be x times the derivative of y. Remember, it's just y to the first, so they would just put y prime. Plus, and then it's y times the derivative of the first function. Derivative of x is 1, so this is just 1. I just leave it out. You can put it in if you want, but you don't need to. Now the next one does have y to the second, so there I do have to use the power rule. So this would be 2y. Okay, 2 times the 1, and then subtract 1 from the 2. That becomes just the 1. Okay, but then you got to multiply because it has a power other than 1 by dy over dx, or I'm going to use y prime. Y prime equals 2. And then on the right side, the derivative of constant, that's your regular formula there, is 0. And the derivative of minus x, again, standard formula there, minus 1. Okay. So then I want to solve for y prime. Okay, so I just collect all the terms that have a y prime here. Okay, so that's this term and this term. And what I'm going to do is I'm going to leave these on this side and factor out the y prime. Okay, so I'm going to factor out the y prime from those two. That'll give me x for that one. And over here, this will give me a plus 2y. Okay. Then on the other side, I just have negative 1. And then the terms on the left side, they don't have a y prime. They go over. So this goes over, minus 3 x squared. And this y goes over. It becomes minus y. Okay. And then I just divide through by x plus 2y. Okay. So then I get y prime is equal to minus 1 minus 3 x squared minus y. And then both sides are divided by x plus 2y. Okay, so this is your derivative computed implicitly. So again, the basic steps in computing the derivative implicitly is simply take the derivative term by term, left side and right side. If it's terms involving x, use your standard formulas. If it's just a y by itself, it's y prime. If it's y to a power, then you have to use the power rule on that formula. So if it's y to some power n, you take the derivative of that with respect to n, and that's going to give you n out here, and then y to the n minus 1. and then multiply that. Don't forget to multiply that by either dy over dx, or I'm using the short form y prime, okay, instead of dy over dx. Okay, and then basically you solve for y prime. So collect all your terms that have a y prime, like I did here. Everything that doesn't have a y prime, or dy over dx, if you use the other notation. Those terms that don't have the y prime, take them over to the left side, and then factor the y prime from the terms that do have it, and solve for y prime. Okay, so this is how this is done. Okay. Now remember, the derivative, one application of the derivative is to evaluate it, and the general idea that happens is when you evaluate the derivative at a certain value of x or y, it gives you the slope of a line tangent to the curve at that particular point. Okay, so let's go to another related problem here. And let's look at this one. This one, number 3, it relates back to problem number 2. It says evaluate the derivative of y with respect to x for problem 2 at 0, 2. Okay, so in other words, find the value of the derivative at 0, 2. Okay, so in this case, okay, this is the derivative that I got. Okay, and again, the order might be a little bit different, but you might get it, and you might get minus 3x squared and minus y over here. As long as the signs are the same, it's the same thing. Okay, so now I want the derivative evaluated at 0, 2, at the point 0, 2. So all you got to do is over here where you have an x, you put a 0, where you have a y, you put a 2. Okay, so this will be minus y 1 minus 2, and then x is 0, so this third term cancels, and at the bottom put a 0 where the x is, so this will be 0, 2 where the y is, 2 times 2 is, this is 4. So compute that out and you get negative 3/4. Okay, so that simply tells me that the slope of the tangent line to this particular curve at the point 0, 2 is negative 3/4, or negative 3/4. Okay, so this has two parts. It says evaluate the dy dx for the problem 2, at 0, 2, and when x is equal to 1. Okay, now notice this one doesn't give me the complete point. It just tells me x is equal to 1. Okay, here x is equal to 1. Okay, so for part 2, let's clear this. For part 2, let's go to the original expression. Okay, so in other words, when x is equal to 1, we have to know the value of y. See, in this one, in the first part, they gave me the value of x and y. Here, they just tell me when x is equal to 1. So I have to find the value of y when x is equal to 1. Okay, so what I do then is I come back to this, the original expression, and we'll have an x, I put a 1. Okay, so 1 cubed is going to be, 1. Okay, so put a 1 there. 1 cubed is still 1, plus, put a 1 where the x is, so it'll be 1 times y, so I get the y there, plus y squared. Put a 1 where the x is, so that's 4 minus 1, this will be 3. Okay, and let's just rewrite this. So I get y squared plus y, so I'm just rewriting the expression, so I got y squared plus y, and then I'm bringing the 3 over, so that's going to be minus 3 and 1 is minus 2 is equal to 0. Okay, so what I'm doing here is I'm finding the value of y when x is equal to 1, otherwise I can't solve the problem. Okay, so this is a quadratic, so I can factor this. y plus 2, y minus 1. Okay. So this, of course, would tell me that then y is equal to negative 2, or y is equal to 1. Okay. So I have 2 points then. I have 2 points. I have one point then would be the point x is equal to 1 and y is equal to 1. So that would be 1 point. So you have 2 possible answers there. And then x is equal to 1 and the other value of y could be negative 2. Okay. So here we go then. At the point when x is equal to 1, y is equal to 1, so I have to plug those numbers in there. Okay. So y prime then, so I'm doing this part right here. Y prime is equal to, okay, so this will be minus 1. Y is 1, so this will be minus 1. X is 1, so this will be minus 3. And then at the bottom, x is 1. Y is 1, so this will be 2. Okay. And then we do the calculation. So minus 3, minus 1, that's minus 5 over 3. Okay, so this would tell me then that the derivative of y with respect to x at the point when x is equal to 1, which means y is also 1, is negative 5/3. Okay, so that would be your slope of the tangent line at that particular point. Okay, now when x is equal to 1, y can also be negative 2. So we have another possibility. Okay, so now compute this out. So for 1 and negative 2, okay, here I have negative 1, y is a negative 2, and then a minus a negative 2, so this will be a plus 2. Okay, minus x is 1, so that'll be 1 squared is 1, and the minus 3, that stays minus 3. And then at the bottom, x is 1, okay, so that'll be 1 plus, and then y is negative 2, so it'll be negative 2 times 2, that's a negative 4. Okay, so then this will be negative 1 plus 2 is 1, and negative 3 is negative 2. And then 1 and negative 4, that's negative 3. Negatives cancel out, so this gives me 2/3. So this tells me then the derivative evaluated at the point 1, negative 2, x equal 1, y equal negative 2, comes out to a value of 2/3. Okay, that'll be the conclusion to this video. Thanks for watching, and I hope this helps you out. See you next time.